This is part 284C3m1b7c8a. Line 22f1fa19c3m1b7c8a. Spectrum copper clusters X-rays free electron pulse 5G Wow Seti. There's the alien radio signal, and this is videos about laser beam pulse for UFO engine, crystals formula, inventions, copper atoms, dimers with argon mixture ideas. So December 4th, 2012. Today's December 24th. So the keyword visible spectrum copper atoms from the previous video of line 22f1fa19c3m1b7c5, focusing sectable multiple quadrupoles magnets 5G Wow Seti. So I'm going to quote from a PDF file: copper atoms and copper clusters in solid xenon, special atom and dimer sites in covalently bound clusters with 3 to 5 atoms. That's from 1983 from pubsacs.org. Another PDF file, because optical spectroscopy of copper clusters atom to bulk. Copper clusters containing 2,5 atoms and large colloidal particles of copper were formed within matrices by co-condensing metal vapor with argon, methane, and dodecane onto a low temperature substrate. The electronic absorption spectra of the resulting solids were recorded in absorptions belonging to individual aggregates of copper identified using a previously published calculation which predicts the cluster distribution within matrices of given metal to host ratios. The birth of the band structure of copper is clearly visible ongoing from the dimer upward, with Cu4 already possessing many of the features of the bulk metal. And that's from jcp.aip.org. So the keyword copper clusters X-rays, quote from the PDF file, is small copper clusters studied by X-ray absorption near edge structure. And that's 2012. The local structure of copper nanoparticles grown in organic solution by reducing the Cu to hexafluoroacetylacetonate was studied as grown by the CUK edge X-ray absorption near edge structure, XANES. Comparison of the experimental XANES spectra with reference materials indicated small copper clusters are formed by ligand-exchange with oleamine and the subsequent reducing by diphosylane. The multiple scattering calculation for various model clusters consisting of 13 to 135 atoms suggests that small 13 to 19 atom Cu clusters are stabilized without a large deformation. And that's iap.aip.org. Another quote from a PDF file from May 1986, structure of the copper cluster in canine hepatic metallothionein using X-ray absorption spectroscopy. The metal binding site in the lysosomal copper methanoline from canine liver was examined with X-ray edge and extended X-ray absorption fine structures XANES spectroscopies. The K absorption edge spectrum of glycol was consistent with the coordination of univalent copper. The Fourier transform of the XANES data showed 4 resolved shells of backscattering atoms. Comparisons between the phase and amplitude functions derived from the isolated shells to those of Cu, Cu, Cs, and Cun. Model compounds showed that each copper was coordinated by 4 sulfur atoms at a distance of that. Analysis of the outer shell indicated backscattering copper atoms at this, and interatomic distances determined from the XANES data were compared to the distances observed by X-ray crystallographic analysis of adamantine-like clusters containing 4 and 5 copper atoms and a cubic cluster containing 4 copper atoms, structurally similar to the 4Fe4S clusters in some ferredoxins. The results of these comparisons suggest that the copper complex in Lycop is arranged in an adamantane-like cluster. The structure derived from this protein may be conserved in other copper methanolines PMID. That's from www.ncbi.nlm.nih.gov. Quote and diagrams are from a blog, a new infrared free electron laser. That's dx.doi.org. Abstract. Okay, the operation of a new ultra-compact diffraction grating coupled free electron laser, FEL, has been demonstrated. The basic elements of the device, which is termed a grating coupled oscillator, or GCO, are the beam and a scanning electron microscope and a diffraction grating, which is mounted in the E-beam focal region of the SEM. The E-beam is controlled by the SEM's electron optical system, and distributed feedback is provided by the grating itself. Recent experimental results are presented, and techniques for extending the wavelength and power coverage are discussed. So here's a diagram. It says cathode, one anode, and aperture alignment coils, first lens, upper scan coils, stigmator, lower scale coils, second lens, polythene window for radiation, and this is your E-beam Faraday cup, and that's called the SEMGO. SEM and then GCO. This is a typical power versus beam current relation graph. Radiated powder beam current. Time, beam current, and detector response. A single unaveraged FIR output pulse solid for an E-beam pulse dotted near the high end of the SEM range current range. The wavelength is approximately 500 that. The grating period was this, 168, and accelerating potential is 25 kV. Power spectrum and wave number. Okay. Typical spectrum produced by the Merton Puplet and interferometer. The line width is comparable to the resolving power. This is wave number period. Measured wave numbers in units of the grating periods versus relative beam velocity. 3 orders are shown. And Elsevier Science, www.sciencedirect.com, December 4th, 2012. So the formula from the PDF data. I'm going to take copper atoms, copper clusters, solid xenon, dimer sites, covalently bound clusters, 3 plus 5 atoms, large colloidal particles, matrices, co-condensing metal, vapor, argon, methane, dodecane, low temperature substrate. Electronic absorption, spectra, copper, calculation, cluster, distribution, matrices, metal, birth, band structure, copper, dimer, upward. Bulk, metal, copper, cluster, X-rays, Google, CU4. Copper, nanoparticles, CU2. Hexafluoroacetylacetonate, XANES, spectra, ligand-exchange, olymine, dufacellane, CU clusters, stabilized, no large deformation. The keywords to go in the next video are large colloidal particles and dimer upward. There will be, there's a list of all the words. The next 2 are going to be covered in the video, and then of course the videos after that, there's like 20 of them. Okay, thanks for watching. We'll go into the next one.